So hello and good morning or afternoon, wherever we are in the world. Welcome to the webinar combining local content and global industrialization challenge for commercial floating units, hosted by us at Reuters events with our partners, Naval Energies. There are over 1,000 of you signed up today, so thanks so much for an excellent response. And thanks, of course, in advance to our speakers, Laurent, Schneider-Maunoury and Christophe Dorignac, if I got that correctly, from Naval Energies, and Ignacio Andorjo from Iberdrola for their time. Just a bit of housekeeping before we begin. Yes, we'll be recording this all and we'll be sending this to you afterwards, along with the presentation. And the format for the discussion will be a 30-minute presentation from Naval Energies, and then we'll be taking questions and answers. We want this to be interactive, so do ask your questions. There's a chat box and a Q&A box, so we'll do our best to get round to them. Without further ado, let's begin with Laurent to start the session.
Well, good morning to all of you from everywhere around the world. I'm Laurent Schneider-Maunoury, the CEO of Naval Energy, Next, and very happy to welcome you at this webinar. Naval Energy is to be an industrial unicorn dedicated to marine renewable energy, inheriting of 400 years of marine experience from our mother company, Next, having hugely invested in innovative technologies. Our mission is to serve our customers, developers, or utilities who want to own renewable energy assets and who also want to have a long-term partner at their side throughout the product life cycle. Naval Energy is responsible for design, construction, installation, deployment at the final position, and maintenance to the life of the project, Next. But the way we are thinking and designing our products for minimizing their total cost of ownership. We've been working on this subject, getting international certification that prove the robustness of our technology for more than 10 years on floating wind, but also on ocean thermal energy conversion. We also worked for Microsoft for the first of that kind submarine data center. This represents a fantastic move forward to make data center more environment friendly in the future. Next. But let's concentrate on floating wind, for which we intend to provide anchored and deployed floating platform at seas. On these huge markets, three main geographic areas are identified for the near future. That means in the coming decade, with existing small projects, but also with promising first commercial scale project, Next. Those areas are Western Europe, Eastern Asia, and the US. But on a more longer term, the market is huge. From Carbon Trust forecast, 70 gigawatts of floating wind is to come to reality in 2040. That means, depending on the size of the turbine, between 4,000 to 7,000 floating units to be manufactured in 20 years. So we are talking about products that will be manufactured by tens per year by each provider. That is a challenge that Naval Energies, the world player, is already preparing. Christophe has this fantastic responsibility. Christophe, the stage is yours.
Thanks, Laurent. Good morning to all of you. I'm Christophe Dorignac, so Industrial Manager for Naval Energy. The demonstration industrial process definition is quite straightforward. Moving to mass production phase is an exciting and challenging topic, another story. And today I'm going to present you the methodology and orientations that Naval Energies has developed to address this topic. So first of all, let's have a global picture on how we deal with that. And the first step, of course, is to understand the main drivers that are, let's say, driving this mass production process. So of course, we have input data from the market, obviously volumes, the projects, wind farm location, global floating volume per macro area, anticipated cost objective, and of course, local content requirements. In terms of industrial capacity, which is another big driver, we need to understand the in-place and future activities and capacities for assembly, manufacturing, installation, and all the different parts of the group. And finally, offshore activities understands weather condition to understand and define the limited operability windows and the seasonal activities. Starting from those variables, we have developed typical scenarios that I will present later on, which are, let's say, typical one that are addressing different type of projects. And based on our understanding of the local capacity, industrial capacities, and on the global industrial process, we adapt those typical scenarios to a precise declination on the dedicated project. That lead to a project execution definition and of course, definition of the investment required. So, first of all, the key point here is to understand that there is two parts in this mass production process, which is on one part, manufacturing and installation, which is mainly a yearly activity, so manufacturing. And the other side, installation at sea, which is seasonal. So you have to deal with two different rhythms, which is a big challenge of this activity. So again, manufacturing, where obviously you can't stop your activity for part of the year, and you have to be efficient and continuous. And the other side, installation at sea, which is seasonal, and which, if I take, for example, Scotland or Brittany, you have about 3, 4, 5 months to operate. So it means that you have to combine those two rhythms, and the key point here will be storage at sea and storage onshore. So the methodologies that we have developed to try to, let's say, optimize and find the good equilibrium is to run in parallel, first, an operability analysis that gives us the exact window that we can aim for installation. In parallel, we ran a manufacturing methodology analysis based on the selection of our best typical scenario, adapt it to the site, and then do optimization loops to be able to define the best equilibrium between efficiency, cost, and schedule. And it leads then to an execution plan optimized. Let's go now, before talking about scenarios, about the global process, which is, let's say, quite the same for the different scenario, which is how we go from steel procurement to installation. So, considering the size of those floating units and considering mass production, of course, those units, those floating platforms are built first into subparts that will be manufactured in different yards, specialized on the, let's say, the type of blocks we are considering. Of course, if you look for columns or for pontoons or for central nodes, this is addressed by, let's say, different specialists. And to get efficiency in your global process, you need to address it through different specialists and not generalist companies. And obviously, in the macro area concerned by the firm. We then go to an assembly phase of the floating platform. I will talk later on about the locations of all those activities. Then there is, of course, the integration of the turbine, okay, which is done by the WTG contractor. And then we go for installation of the different units. So here are the three scenarios, typical scenario Naval Energy has defined, which are of course typical, and then will be, let's say, combined and customized during the declination phase to stick to the capacity in terms of harbor or industrial. The first scenario is a temporary production one, which is used for small farms or isolated sites, meaning from 2 to 10 units in terms of demonstration, or where you have any industrial capacity, you are insulated. I think about islands project, for example, like La Réunion. Scenario 2 and 3 are quite the same in terms of spirit. The difference in the continuity and the visibility we have in the future to continue the production. So the base of those two scenarios, to think about fabrication of mega blocks in different yards, locally or out of the country, according to the capacity of the site we are considering. Then the development of an assembly hub to assemble all those blocks which are transported by HTV. This assembly site has to be, of course, as close as possible to the site. And there's two options. Or we consider integrated in this assembly hub the WTG integration. And if it's not possible because the surface is not enough, we will consider two different sites. And then, of course, after assembly, we launch it in the water and then go for installation phase. The difference between scenario 2 and 3 is mainly about the means, industrial means we are going to use. In the case of scenario, when you have enough volume to consider an assembly hub, but you don't have the visibility over the years, over a decade, to invest heavily in different means, adaptable, mobile, repositionable means will be used. And in case of visibility, we could invest in much more heaviest industrial means that will help us to go even more into the cost efficiency and use this hub like a permanent factory. So let's go first on scenario 1, which is quite, let's say, simple to understand. That's the one which is mainly used in demonstration phases. So again, complete floating platform manufactured and assembled in one yard, transport into HTV, WTG integration and installation. So this is, let's say, a typical schematic of what could be integration site. Of course, it's typical. Here, there is no, let's say, it's not representing a real project, and the number of storage is important there, but it's just to show a principle. Those storage capacity, we define some tools to be able to, let's say, define accurately what kind of storage we need. As concerns scenario 2, so again, I repeat it, fabrication of subparts manufactured in dedicated yard in the macro area concern. When I say macro area, meaning Europe for European project, or Asia for Asian projects. And this typical layout that you see here represents, let's say, the floating platform assembly that could integrate the WTG integration also. It's based on the first in, first out principle, where you see, let's say, no flooding of sub blocks on the top of the layout at the left. Then you go to store your different subcomponents, mega blocks, on the right side of the layout, and then you push into a line of production. That, of course, will be based on production lines, and the number of production lines will be adapted to the volume, and of course, will go up during the ramp-up phase from 1 to 3 to maximum three production lines, we think, to be able to deal up to 25 units per year. So of course, in this layout, you will have first assembly, so steel assembly of the different mega blocks, then painting activities, commissioning phase, potentially integration of floating units, which could be important. As I told you, we are going to assemble during all the year. And a part of the year is not on the critical path. And what will be important is to have at the beginning of the seasonal windows, the maximum floating units ready to be installed. If you consider the total integration phase of the floating of the turbines during the beginning of the operational window of installation, you potentially lose time. So, and this is a key point. Install 25 floating units in a 4 months period is quite challenging. So every weeks, I would say even every day is counting. So find synergies between the different activities seems for us the key point. So in case of scenario 2, again, which is let's say, to address one project with no visibility in the future, we are using repositionable means, meaning that we'll go for, let's say, lighter means and potentially for rental or rental equipment, and not dedicated specific tools for it, but trying to aim efficiency. In terms of scenario 3, where you have a visibility, then you could go to, let's say, permanent equipments that will lead to the maximum efficiency expected, meaning that you can install, let's say, lines of transfer, ring cranes, gantry cranes, launching system, which could be, let's say, even permanent. So meaning that you could really go to the factory spirit to go to the, say, industrial efficiency. In terms of anchorage, it's quite more standard subject. So the requirement is more or less surface from 5 to 12 hectares to storage the different components of the anchorage system, depending on the volume of the farms, and to get enough key to be able to, let's say, load those equipment, and of course equipped of lifting capacity, much more lighter than for assembly phase, of course. So I think a little more easy to address straightforward. If I come back to assembly phase, I will say that the requirement is between 40 to 60 hectares according to the volume considered, and that in the first analysis we have made, we can say that, for example, for Korea, France, and Scotland, first analysis we did, and US, the surface are there. We find them now. It's about to understand the potential common investment and definition with local authorities and harbors to prepare them. That made a joint with local content, which is here a key point, of course, for the acceptability of projects and the wish of all the actors of floating unit industry, floating wind industry. Of course, we need to think about local content. First, understand what are the requirements, and closely understand with stakeholders, with local authorities, understand what are the capacity existing, what could be the evolution in investment to define the best equilibrium between local content, cost efficiency, and local development. So I would say there is two main scenarios there, maybe three. The first one is to consider a full scope in the country. If the country or the location is highly industrialized and have the good capacity, we could consider a local 100% scenario. But in real life, we could reach to a partial saturation of the different capacities. And in this case, we will use a combined one, again, in a close discussion with local authorities and industrial, to find the best equilibrium to, at the same time, maximize local content and be able to follow the target in terms of cost and schedule of the projects. So if we go for a quick analysis of the different items, I would say there is 2 or 3 different types. As concerns steel procurement, we don't believe, as concerns the volume and the specificity of the activities, that it could be considered as local content. For the central and external columns fabrication, so the mega blocks, we do believe that will be a combination of both. Surely at the beginning, we will start with a small amount of local contents, and with, let's say, the ramp up of industrial capacity in the site, on the site, we could increase it and go, we think, to 60% of fabrication for mega blocks. Same for pontoons. As concerns the final assembly, and I deal here with mass production, so I will exclude scenario 1. With the organization we proposed, final assembly will be 100% local content, which is a big part of the job and the key point. And more than the volume, it will require high skill and a real knowledge that could be even used by companies then to go for other activities. As concerns vessel operation and support activities, that's the same that for production. We don't believe that we will find 100% at the beginning of the project and the beginning of the mass production story, all the different means, but local industrial will ramp up in parallel to the process, so we could go to 50 to 100% local content on this topic. And finally, on, let's say, the different infrastructure, industrial means, specific means mooring systems and equipments. We do believe, obviously, ground rental area will be at 100%. And then on the other one, it will be the same that for, let's say, installation means. We will go for a small amount at the beginning, and with the volume and the different requirements of the project, the areas will equip them, and we could ramp from 50 to, let's say, 70, 80%. Why I'm not saying 100%? I'm not sure that, for example, for big crawler cranes or ring cranes, we will find all the time local supplier, which is more a world topic. Thank you for all.
Fantastic. Thank you so much for that presentation. Really good detail, and the audience are asking all sorts of questions, so a lot to get through. So let's fire away. I think it's a good time to bring in, obviously, Ignacio into this from the developer's perspective. I wanted to hear your thoughts on the presentation and how Iberdrola are approaching this challenge. Oh, you're just on mute, Ignacio.
Yeah, okay. Now, first, thank you very much for inviting me to this webinar, especially to Naval Energy and to Reuters. Regarding what Naval Energy have just explained with their presentation, I fully agree mainly in 2 issues, or maybe 3. The first one, Naval Energy is indeed a unicorn because it's one of the little technology developers that they have as well, manufacturing capacities. And that is quite interesting from a project developer or a final client like Iberdrola could be as an utility to have the technology and the capacity in the same company, because we always target to EPCI as much as possible in order to minimize the packages that that we will have. So that is a very interesting point regarding naval energy if we compare with other potential technologies. The second point in which I fully agree with is that the key for reducing the final cost and improving the LCOE for several locations is the mass production. So we should be able to produce in a reasonable time, let's say 2 years of fabrication as a maximum for a 500 megawatt project, being able to deliver 20 something units during those two years as a minimum. So that is the main driver for reducing the prices and the cost. And the third point that I fully agree with Naval Energy presentation is that local content is becoming the main driver, or one of the main drivers and requirement in the floating rounds in all countries. So what we have now on the table is the Scottish round and the French one. So this Scotland is open an ocean, and we will have to submit the first phase proposal by the end of March. And there, the local content will be one of the main criteria to evaluate the proposal. And in France, for the Brittany project in South Brittany for floating, is more or less the same. So it is key to understand what really local content means, what are going to be the criteria to evaluating and comparing one offer versus another, which will be the priorities to maximize the manufacturing in that country that is calling for the ocean, or maximizing the investment, or maximizing the revenues. And that is something that all the developers that we are involved in this auction are trying to clarify with the local authorities. So in general, I have nothing else to say to this presentation. I do really agree with all the points. As a developer point of view, we think that we are in a very interesting point where most of the technical challenge have been already reviewed. So this phase in which we as a final user challenge certain design is almost over, with a very little exception. It could be TLP technology that they are not sufficiently proved so far. So for me, or for Iberdrola as a final client, if we are involved in pre-commercial or demonstration project is not for the sake of testing the technology that is in the hands of the technology developer. For us, the most important is to manage those demonstration projects in which we can control the potential risk and impact, but to manage in the same way that we will want to manage the next step commercial projects, in order to first analyze all the supply chain and localize what are the weak points and that supply chain and the bottleneck, and to be ready to tackle those bottlenecks. And second, to optimize all them and to understand all the manufacturing phase and the manufacturing procedures in order to reduce the cost. The third point is installation, and I think installation is part of the strength of the floating offshore wind solution if we compare with bottom fix. In most of the areas that we are analyzing now, the distance to the shoreline is not so big that will not allow us to go with the assembled unit, meaning the floating platform plus the turbine and tagging away, allowing us to do the assembly at the port or at the marshalling port and then tag away to the site. Taking off from the equation of the installation process all these vessels, like jacket vessels or DP3 vessel or very demanding vessel, that makes really hard to manage the program of a floating of a offshore wind project. In that point, that's is one of the strengths that we should encourage and to work with the turbine OEMs, or the manufacturer of turbine, and the technology developers for the floating platform plus the manufacturing facilities, in order to optimize this installation process.
Fantastic, and that sums up, nicely. Obviously, Schroeder's thoughts and position in the market. Some questions that I've seen coming in quite a bit are on yards. So Nadia and Antoine have been asking about this. I think for Christophe, what's your view on how to manage storage space at a fabrication yard, and just your general opinions and thoughts on managing space and ports?
So our obviously first is to discuss closely with harbor authorities to find those areas. And one of the key points is the surface. Second one is the bearing resistance. Here we talk about floating platforms that can go from 3,000 tons today to even more when the power will increase. And secondly, to really understand the different flows, as I said, between manufacturing and installation, give you the storage requirements. So that's the key point. Then you can also consider, let's say, floating storage. But for the analysis we have done today, it's because the different sites that are preparing projects are preparing surfaces onshore. Today, the key length is quite expensive and rare. And we have to, let's say, share those key lengths with, let's say, commercial activity. So I do believe that we will have a combination between storage at sea and onshore, considering also that store floating units like that during winter at sea or even in a harbor in a floating way will add some cost and also some risks, especially in regions like Scotland or Brittany, for example, where you could have, say, specific risk on that. So I would say that I will rather go for onshore if the surface are there and launch at the last minute during the seasonal activity, more than floating. But in the reality, I think we'll go for a combination of it.
Fantastic. And I think another questions that I'm seeing coming up a lot is on geography and regions. So it's specifically, can you use this model and framework for different regions, and can you use this approach successfully, obviously in Asia, in Europe, in America, in all those markets that you showed that there's growth? I think let's go with Christophe again to start that, and then hear from Laurent and Ignacio too.
Okay, so first of all, it goes through a local presence of Naval Energy, and a local presence or a local presence by his own of Naval Energy or through GV, to be close from, let's say, about close to industrials, to understand, anticipate, and prepare the sites. If you do so, you are able to, let's say, understand what will be the specificity and the capacity today and also of the future, because we talk about long-term development. And knowing that, you can use, as I say, those typical scenarios are, let's say, theoretical one. And the reality will be a combination of it, adapting to those local capacity and specificities. So I will say that the solution is to anticipate and discuss closely and continuously with authorities and industrial locally to understand.
Ignacio, any additional comments?
Yes, in general, one of the reasons because Iberdrola have not chosen a particular technology to go with, and we declare ourselves agnostic under the point of view of the technology, although sometimes this agnosticism is not very well understood, is because we always are going to analyze the most suitable technology considering the meteorological conditions of the particular site, plus the manufacturing capacities of this particular area, and the turbine that we will select for that project. So although we have analyzed about between 50 and 20 technology in the last almost 10 years, especially focusing in commercial projects during the last 2 years. We have our own short list and we have our own preferences, but we will not do a binding relation for more than one project or a set of projects with a particular technology, because it's key to analyze each of the location. No, because the customization of the platform for this particular meteocean condition will be the main driver for the reduction of the cost. But the manufacturing capacity of the areas, yes, that will be the main driver for maximizing the local content and eventually for the reduction of the cost.
And Laurent?
Well, in our view, as I said, the volume to be produced will be in the next 20 years absolutely huge. We're talking about, I said, between 4,000 to 7,000 floating units to be delivered in 20 years. So we believe that we'll come to product-oriented solution as you could find on other major equipment. So that means that we in our strategy, we need to be able to replicate on the different location the same industrial way of manufacturing our products. That will be the only way for us to fulfill two things. First of all, the ability to deliver the rate requested by the customers. And secondly, being able to request the cost requested by, be able to deliver the cost requested by the customers. And I believe that the customers will have the choice of products, combined products, a couple of wind turbine, floating units, fitted one for the other, and they will choose the best combination for a given meteocean and local conditions. And that's as an airline is choosing between two airplanes to fit their routes. I believe that the developers will have to make the same choice. What is the best and the fit for purpose products combine engine and turbine and floating foundation to suit my project and to fit my project in terms of times, in terms of technical conditions, in terms of cost.
So on that then, to keep those local authorities updated, how are you reporting to, and updating them? Laurent,
well,
start.
I will. If I may, all these, this industry is huge by the size, huge by the quantities, and also is a long-term industry. So that means we are working with the local stakeholders from now to prepare the future that will come in 3, 4, 5 years. I've seen one question: when will we see the first commercial to be deployed? And we believe, maybe Ignacio will contradict me, we believe that the first commercial will be deployed at the end of the decade, 27, 26, 7 or 8 time. We will see the first deployment of the commercial farms. So it may seem to be in a long way, but we have so much work to do before that we need now. And we are now working with the stakeholders. We're working with the harbors. We're working with the different location in the different location to, as Christophe said, to understand their request, to understand their capacity, and to build that and to do that together. We'll have one day also to work with the local people to set up the workforce, because to assemble at the rate of 10, 20 per year, these sort of huge products, you need qualified people. You need people that are able and do it at the right time with the right quality. And that is not always available everywhere. So we are also working on with the local authorities on these points.
So it's a lot to consider then. So that, of course, Ignacio, then additional comments, and also to add that question back, Ignacio, to consider too, how are you going to be able to source a high quality local workforce, considering particularly now it is a newer technology?
Mm-hmm. Yes, as Laurent has said, those look like that they are going to be a long-term projects, but the end of the decade, so 2027, 2028 will be here very, very soon. So we have not so much time, and maybe even we will have some surprise in some market like the Asian market that is extremely active. And maybe they will speed up the first COD for the first fully commercial project, meaning more than 300, 500 megawatt. So although it looks that we still have some years ahead, we have to start planning now, and indeed we are already planning during the last 2 years. And regarding the manpower, local content, that is something that we will have to do it together, the manufacturing, the clients, and the local authorities, foreseeing what we will need in a few years' time. That's one of the reasons, because Iberdrola analyzed for each of the projects which is the most suitable technology. In some areas, you have a lot of manpower specialized in steel, and there is no big issue to find welders or quality inspector, although those projects will most likely require most of the resources in that region. In other areas that will be quite complicated, we have two chances of changing the technology and going, for instance, with concrete, if there is concrete capacity in that area, or to encourage those countries or areas to speed up the process of getting skilled people. And for doing that, you only can or train local people or bring people from outside. So, and for doing those kind of projects, there is no country in the world, as far that I am aware, that they will be able to supply 100% of all the services and equipment that those projects will need, exclusively with local content. So there are already launching several initiatives. For instance, in Spain, there is a hub in the north of Spain called the Cantabric Hub, where they try to articulate relation between all the supply chain, not looking only to the Spanish market, because the Spanish market will be a few gigawatts, but looking to the neighboring market, like Europe, Scotland, UK. And in UK, they are doing something similar. They are creating hubs. So at the end of the day, although we have to maximize the local content, but we will, if we want to keep a balance between the actual cost of the projects and maximizing the local content, we will have to articulate all these kind of relations. If not, it's going to be really hard to make a project bankable. And to make a project bankable, we have to do engineering as usual, engineering and design during the first 1.5 to 2 years maximum, most likely less. Fabrication 2 years, installation 2 years. If we have to laminate all these progress curves because we have not the capacities enough, or because the requirement of doing the manufacturing in one particular facilities are too strong, and we have to make it longer, the manufacturing process, that will increase the final cost of the project and even could jeopardize the project itself or the viability of the project. So at the end, although everybody is keeping in mind local content, and that is really important, and those kind of projects, they are tractor projects to create the network and the tissue for supply chain, local supply chain, we have to be realistic. Not everybody can manufacture a turbine, because for manufacturing turbine, you need a few years to create the facilities. Not everybody has deep enough water harbor to do the assembly of the turbine and the floating platform. So we have to be realistic, keeping in mind what are the local requirements that everybody understands. That those projects have to leave most of the benefits in the area where the project is developed, but to be realistic and to encourage this kind of relation between hub, industrial hub, and supply chain hub between different regions.
I see Christophe was nodding a bit during that. So do you have any added comments as well, Christophe?
Yeah, I would say that if floating unit industry is quite new, the skills required are well known. Ignacio talked about welders, about quality inspector, lifters, etc., mechanicals, commissioning. So the key point here is anticipation. We know that in some country today, there is a huge activity on oil and gas or naval industry, which are requiring the same skills. And the key point here is anticipation, dialogue with local region, local authorities, to put in place the programs and trainings to be able about over 5 to 10 years, increase the capacity on the different skills. Our side is to be able to give them the requirements and capacity of what they require, and them to put in place those training programs and let's say move. We talk here about hundreds of extra welders. I think that for assembly phase, for example, welding will be a key point. But you have also some specific other skills. Quality inspection, for example, will be a key point. And this will be treated by anticipation. Just go through the location and say, okay, in 2 years we have to launch a project. Of course, workforce won't be there. So it's again anticipation and close dialogue.
So and on local content, Noel asks, how do you see local content requirements fitting with competition regulations? Laurent, any issue there?
I didn't fully understand your question, sorry.
So Noel asks, how do you see local content requirements fitting with competition regulations? Do you not see any issue there?
Well, I would say that's an interesting question, because you have some area of the world where local content is requested, but sometimes in some ways forbidden. So that will be, I would say, the subject is to be asked to local authorities. We will as product manufacturer, as product provider, will adapt ourselves to the constraints that we will receive. And as already said previously, there will be a balance between the cost and the local content, and the cost and the constraints. If you have a lot of constraints, you have a higher cost. So we are working with the also on the long-term thinking with the authorities. We Naval Energy are talking with the EU's authorities to explain what will be the different leverage on this new industry, and what the regulation can make to develop them.
And Ignacio, have you encountered this challenge at all?
Oh, of course, local content have to be very clearly explained in order to do the best offer that we can submit to the local authorities, and that will be an advantage for the developer that we are participating in the bidding process, and to the local authorities and the country that will have the best offer. The difficulty of local content is understanding what are going to be the evaluation criteria whether it will be the weight will be more in potentiating the manufacturing locally, or the employment, or both, or the revenues, or the lower price as possible. So, and that is an exercise that have to be done by the one calling for this option, mainly local authorities, the ones presenting the offers. Well, we are in these conversations, and we have learned, fortunately, from the bottom fixed projects, where the prices have been reduced dramatically during the last 10 years, and the tariff that is being offered by the local authority has been reduced dramatically too during the last 10 years. Even some of the projects are going with no fixed tariff. In floating, I think that will happen in the same way, even quicker. But in order to avoid any mistake, like in the past, in which several conditions of ocean will have to be reviewed and revisited even after awarding the final developer of a particular project, for floating, we will have to do the same. We will have to clarify what local content means, to put in a balance that maybe it is worth it to have slightly expensive project if we maximize the impact in the local communities, or in the other way around. That's for minimizing the price, we need to externalize from this, out of this region or country in particular, some of the especially the manufacturing process and the manufacturing scopes. But local content is very easy to say. I want to maximize the local content, but have to be defined.
Well, just also made to add something on Ignacio. Sometimes the local content is not physically feasible. If you are looking at the local content of a town, for example, of a real small one, there is not the industrial means to be able to lift a turbine which is around 450 tons up to 200 meters up to the floating foundation. There is no means. You cannot make the local content. So sometimes there's wishful thinking to say, well, I want local content. Yes, but if it's not physically feasible, you can't have it.
And we are going to compete all the developer for almost the same, or exactly the same manufacturing facilities, the same skilled people. If we want to do the project at the rate that Europe, or in this case UK, is thinking that we will have to deliver about 11 gigawatt in Scotland. That is the ocean that is about to start. And in Europe, they are talking about, the local authorities, they are talking about 30 gigawatts. If we wanted to do it in the period of time that the programs by those authorities are putting on the table, we will have to discuss if it's feasible or not. And we may cover all part with local content, and all the industrial facilities of that area will be working in those projects. But in addition to that, we will need external supplies.
And what's interesting is a question that came through from Williams, who asked, and I think Christophe, you'd be good to answer this one. How do you ensure good synchronization with what Naval Energy is producing and all the components provided by the suppliers?
Well, I think here we talk about the turbine system, for example. So again, we are on some demonstration project today, and even discussing also on mass production. It goes with the common studies. I would say it's forehand studies with the different component owners to manage interfaces, to the rhythm of fabrication, be able to coordinate all that. So of course, the first step, we have developed our own process, one, but discussing with a different turbine provider, for example, with developers about IAC or other components, we have adapted and customized ours not to be efficient by our own, but efficient as a global. There's no sense to say that we have a fully optimized process for certain units and then lose 3 months on the integration turbine. 3 months is just an example. Because we have not considered the correct interface or the correct, let's say, process organization as a whole. The key point is to think global. As I said, Laurent, we talk about a product, and the product is not the floating foundation or the turbine, but it's a group.
Fantastic. And then another question, quite a challenging one, maybe from Gustavo. Could you specify the assumptions of tons per year process/fabricated for 1, steel for floaters, and 2, mooring components for each of the scenarios?
Well, this is a good question, and we could go from a full presentation. So what I said, if I go on scenario 2 or 3, we are trying to address, let's say, a rhythm of 25 unit maximum per year, which I think is feasible because we carry on study on that. So if you consider, let's say, floating units between 2,500 tons and 5,000 tons, let's say 5,000 tons. So for turbine about 15 to 20 megawatts and over. So if you do use a calculation, you will have to globally the process deal with about 150,000 tons of steel, which is huge. If you look today, even existing naval or oil and gas yards capacities, and you select them by this capacity, you have no so big amount of yards. So the key point again is not only to discuss with local authorities, but also with big suppliers who help them anticipate and prepare their tool for that. Sorry to go more in the detail on that, but this is a big question, then we could spend hours on it.
Again, and on the top of what is, as Christophe said, this is a new industry that is not existing today. The figures given by Christophe show that it will be a big industry, and the conclusion of that is we'll have to create capacity. If we want to serve the market, we will have to create capacity, and it's all the challenge of the industry is to invest in creating capacity, because we have the absolute, I wouldn't say commitment, but conviction that this capacity will be used and will be maybe overused because there is a demand.
Absolutely. I mean, we're going up to the hour now, so I'm conscious on final thoughts and comments. I'm just going to give each of the panel a go for that. We'll start with Ignacio, just on this overall topic, maybe some positive thoughts for the future of floating wind, some other industry challenges for our audience, and then we'll go to Christophe and then Laurent to wrap up.
Well, the most positive is that we have a huge opportunity to mobilize a huge supply chain that will benefit a lot of areas, countries, and people. That is the most positive message. In Europe in particular, we are well located because we have in certain areas the resources, the wind resource. In other areas, we have the skilled people and the manpower, and in other the facilities. We are not starting from scratch. We have lesson learned and experience that we can gather from oil and gas and from bottom fixed wind farm. Most of the people that we are involved in floating, we came from oil and gas or from bottom fixed offshore wind farms. So we are not starting from scratch. But we have to be very clear that if we want to deliver all the commitment that the local authorities, the governments are putting on the table, we have to make a very detailed analysis of the supply chain, localize the bottleneck. That's more or less we already have done that, and highlight that, for instance, mooring lines are going to be one of the bottleneck. The companies that they are very good companies that have been supplying to oil and gas, they will have to multiply their manufacturing capacity. Dynamic cables, so far there are not so many dynamic cable already installed, and the manufacturing will have to be increased, and the way we do the calculation and the design of those cable and the installation of those cable will have to be rethought. So the positive message is that we have already learned a lot from bottom fix and oil and gas, and we are in a very good position to do things properly. And that is a huge opportunity to make big projects with a very positive impact.
Fantastic. And Christophe, your additional comments.
Well, I would say that the very positive things for me is about, it's a pure example of green positive development. Of course, we'll go for green energy, and at the same time, as said Ignacio and Laurent, we have to create participate, meaning going for green energy and also bring work to people, develop capacities, and be able to, let's say, bring a huge volume of work and make progress to different existing capacities today in the world, and even create new one. As we said, if we look to capacity today, for example, about manufacturing, they won't be able to, we be able to, let's say, address it with what it is today. So it's a huge and positive challenge to create value and create work addressing a green subject.
And Laurent, to wrap up.
Well, thank you very much. You have understood that Naval Energy is to be worldwide, I would say, equipment producer, a combined equipment producer with local industrial footprints. And this target is to answer the market and the customer request. We are, and we've tried to show you that we are working on it. Standardization, industrialization is our tomorrow's duty. We didn't talk about it, but it's combined things between the floating foundation and the anchoring system and the mooring system. Both needs to be as much as possible standardized, repeatable, in order to be as much as price effective. We are working on it. We are developing the solution, and we have tried to share to the community what solution we are thinking about. We are preparing ourselves for the very near future, which will be the first commercial farms in France, in Europe, and in the rest of the world, especially in Asia and America. Thank you very much, and looking forward to maybe talk to you again.
Fantastic. Yeah, so just as for everyone who's asking, and also thank you so much for the positive feedback. There's been a lot of good comments from the audience. And we'll be sending you all the recordings after this discussion, so do stay tuned and stay tuned for the rest of our Floating Wind Dialogues at Reuters events. And thank you for all of our speakers, of course, for their time today. Goodbye.
Goodbye.
Thank you very much. Thank you. Bye.